Hey, welcome back. In this video we are going to talk about how to name the alkynes. We are going to start first with examples that convert the name to the structures, and the second example is going to be that you have the structures and you have to convert them to their names. Let's start with the first example. Convert names below into the structures. Let's start with the first one, propyne. It contains 3 carbons from prop. Ine means that contains a triple bond. And let's fill with hydrogens. This is the first compound. Let's start with the second one, that it's a little bit more complicated. First, you have to start from the parent name, octyne. So it contains 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Always place numbers. Do not make any mistake. And let's place the triple bond first. 4 octane. So this is the number of the triple bond. Or you can find it oct 4 ine. Okay? So at the position 4, you have the triple bond. 1, 2, 3. So you're going to start numbering from this side if you place numbers in this side. And it contains also 3,3 dimethyl. So at the position 3, it contains methyl and again another methyl. And what is left now? Just to fill with hydrogens. Let's start with the third example. That is quite more complicated because it contains double bond, nonene, 6 ine, and triple bond. As a general rule, when there is a choice in numbering, double bond receives lower number than triple bond. And this is one of the cases. Let's write first the number of carbon of the parent. None, so 9 carbons. Always place the numbers. And now we have to place the double bond first, that is in the first position, because when they are comparable, you have to give the lowest number to the double bond. So in this case, it's at position 1, double bond. And the triple bond, 6 ine, so it's in position 6. 1, 2, 3. Now we have to fill the substituent. So at the position 3, you have chlorine. So at position 3, you have the chlorine. At the position 4, you have 2 methyls, dimethyl. And now what remains? Only to fill with hydrogens. Always make sure that the carbon has 4 bonds. Let's convert now structures to names. You have to find first the parent name, that is the one that contains the triple bond in this case. And the numbering of the carbons will start on that side that you have to give the lowest possible number to the triple bond. We are going to start from this side, 1, 2, 3, 4, 5, because it gives the lowest possible number to the triple bond. If you start from the other side, from this side, you are going to give a higher number to the triple bond. That is wrong according to UPAC naming nomenclature. So the parent name is 5 carbons, so it's going to be pentyne. So the parent name, pentyne. And the triple bond is at the second position, to the second carbon. But we have also a substituent, that is this one here, that is methyl at the position 4. That's why I always recommend to place numbers, because it's easily to name all the substituent after. So 4 methyl, 2 pentane. In the newer naming, you can find this 2 number inside this one, like 4 methyl, pentyne. Okay, so both of these are accepted. This is the newer naming, this is the older one. But either of this will give you a correct answer. Okay, let's move to the second structure. We have a cycle here, and the cycle contains 6 carbons. Okay, so this is going to serve as a parent name, and is cyclohexyne due to the "-ine" suffix. Of course, the triple bond contains the lowest possible number, is at the first position. So in this case, so in order to name the substituent, we are going to start counting to give the triple bond the lowest possible number. So first, second, third. Be careful, don't start here, like first, second, because you do not include the triple bond on that case. So the final name is going to be 3-methyl cyclohexyne. Let's move now to the case that there can be confusion. I said at the beginning that when there is a choice in numbering double bond, receive lower number than triple bond. In this case, you can start from this side 1, 2, and the double bond receives the lowest number, or you can start from here 1, 2, and the triple bond receives the lowest number. If you are in this scenario, you have to give to the double bond the lowest possible number. Okay? Deal. So in order to give the double bond, you're going to start the lowest possible number. You're going to start from this side to place the numbers. So 1, 2, 3, 4. So from here we find the parent name that has 8 carbons. So it's going to be oct 2 in. After that comes the triple bond position that is at the 6th carbon, 6-ine. This is the name for this compound, oct-2-ene 6-ine, or 2-oct-ene 6-ine. Okay, both are accepted. Which one you prefer depends on you. Okay, let's move to the fourth and the last example. In this case, we have double bond and triple bond that are in different positions. I said that when there is a choice in numbering double bond, receive lower number than triple bond. In this case, if you start numbering on this side, it's going to be 1, 2. So the triple bond has the lowest possible number. If you start in this case, 1, 2, 3, the double bond is going to have the lowest possible number. But according to EU-PAC rules, the choice between the priority of the double and triple bond, it depends on how you can possibly give the lowest possible number to these multiple bonds. In this case, the triple bond takes the lead, because it's not like the previous example that we had here, that the triple bond and the double bond were in the same possible number. So in this case, you are going to give the lowest possible number to the triple bond. Be careful, do not confuse this, because this is the only confusion that you can have in naming the alkynes. 9 carbons is gonna be non-6-ene 2nd-ine. And you have a substituent to the position 4-methyl non-6-ene 2-ine. Okay? This is the correct name according to EU-PAC rules. Okay? Thank you so much for watching, and see you in the next video. Peace.